So moving on to the adjustment of a closed compass traverse. So first, what do we mean by closed traverse? So a closed traverse is a group of lines that are joined together to form an area. So it is when the series of lines form a circuit which ends at the starting point. So closed traverse is applied to form a lot or subdivision. However, in surveying, we may encounter problems or may encounter some factors that could influence our data, and that factors could create or could generate errors in our traverse, such as error of closure. So, error of closure is the amount by which a closed traverse fails to close the perimeter of the tract surveyed. Now, we have two methods used in eliminating error of closure in our closed traverse. We have here compass rule and transit rule. But for this discussion, I will only discuss the compass rule since it is the method that we are going to use later to eliminate errors and adjust our traverse, our closed traverse. But before that, let's try to understand some terms that we can find in our traverse. So we have here latitude and the departure. Now, latitude here is either the north or south projection of our traverse, and departure here, this is either the east or west projection of our traverse. So like for example, we have this closed traverse and this will be our point A, point B, point C, and point D. So AB, our line AB here has a north projection, and this projection here is what we call the latitude. So this is our latitude. So it has also an east projection. So we have here an east projection, and this projection here is what we call the departure. So for line BC naman, we have south projection. So this is what we call the latitude, and it has also an east projection, and this will be our departure. So meaning to say that all lines in our closed traverse has a latitude and a departure. We also have to take this into account that in latitude, north is considered as positive latitude and the south latitude is considered as negative latitude. So for departure, the west departure is considered as negative departure and the east departure is considered as positive departure. So we have to take note of this sign convention. So how are we going to compute for the value of our latitude and departure? So take note that we have here angle beta. So this angle beta here is what we call the bearing angle. And we know that bearing angle is the angle which is referred from the north or south lines. So we usually express bearing as angle from the north or from the south. So what is the use of this bearing in computing for the value of our latitude and departure? So let's say that this is our point A, and this is our point B. And the distance between this point A and B is known or present. So we have the distance, and we have also our latitude here and our departure. Now, to compute for the latitude and the departure, we can use, so basically it is just using the right triangle rule or adopting the sum of trigonometric identity. So to compute for latitude, we can use cosine. So we have cosine of the bearing angle is equal to the adjacent. So our adjacent here is the latitude over the hypotenuse, which is the distance. So our formula for latitude will look like this. So we have the latitude is equal to the distance times cosine of the bearing angle. So this will be our formula on getting our latitude. So for distance, so we can use sine. So we have sine of the bearing angle is equal to the opposite of that angle. So we have the opposite here, we have the departure, over the hypotenuse, which is the distance. So our formula for departure will look like this. So we have departure is equal to distance times the sine of the bearing angle. So this will be our formula on getting the departure. So that's all. Now let's proceed to the method that we are going to use in eliminating the error of closure. So compass rule. Compass rule is based on the assumption that all lengths were measured with equal care and all angles are taken with approximately the same precision. It is also assumed that the errors in measurements are accidental and that the total error in any side of the traverse is directly proportional to the total length of the traverse. So here we have the formula used to compute the corrections for latitude. So we have here the correction along the latitude is equal to the error of closure in latitude times distance over the total distance. Now we have the formula used to get the correction for departure. So here we have correction along the departure is equal to the error of closure in the departure times the distance over the total distance. Now let's try to apply what we discussed earlier. So we have here our example with the given data of the closed traverse. So we have lines AB, BC, CD, and DA. So this is a four-sided traverse. Now line AB has a distance of 368.76 meters. BC has a distance of 645.38 meters. DC has 467.86 meters. And DC has a 593 meter distance. Now, the bearing of these lines are for AB, we have north 15 degrees 18 minutes east. BC has south 85 degrees 46 minutes east. CD has south 18 degrees 30 minutes west. And DA has north 77 degrees 35 minutes west. So now let's balance this close traverse using the first method, which is the compass rule. So our goal here is to adjust this traverse. But again, the first thing that we will do here is to compute for the total error or the error of closure. And if we found out that it has an error of closure, then that's the time that we are going to apply the compass rule. But if we found out that there is no error of closure, then there's no need for adjustments. So to compute for error of closure, we need to compute first the latitude for every line and as well as its departure. So let's start with line AB. So to compute for latitude, again, I have derived the formula earlier. So it's the latitude equal to the distance times the cosine of the bearing angle. So for line AB, we have latitude is equal to the distance of line AB, which is 368.76 meters, times the cosine of the bearing angle. So we have cosine of the bearing angle, so we have 15 degrees 18 minutes, and this will give us 355.69 meters. Now take note that our direction here is north, so the sign for our latitude depends on whether it is on the north direction or in the south direction. But for our case, AB here, the direction of AB is along the north, so therefore this is positive. So we have the latitude 355.69 meters. So let's next is we have the line BA or BC. So latitude is equal to the distance, which is 645.38 meters, times the cosine, which is cosine of 85 degrees 46 minutes, and this gives us 47.641 meters. And since the direction of our line is from south, so this means that we have negative latitude. So we have here negative 47.641 meters. Next we have line CD. So we have the latitude is equal to the distance, which is 467.86 meters, times the cosine, which is the bearing angle. So cosine of bearing angle, so we have cosine 18 degrees 30 minutes, and this will give us negative 443.683. So we have negative here because the direction of our line is from the south, so it is negative. So we have here negative 443.683 meters. Now for line DA, the line DA. So latitude is equal to the distance, which is 593 meters, times the cosine of the bearing angle. So we have 77 degrees 35 minutes, and this will give us 127.507 meters. So this is positive since the direction of our line is from the north. So we have here positive 127.507 meters. So now we are done with our latitude. Let's now proceed to the departure. So we have the departure is equal to the distance times the sine and the bearing angle. Now let's start with AB. So we have AB. Departure is equal to the distance, so we have the 368.76 meters times the sine of the bearing angle. So we have sine 15 degrees 18 minutes, and this will give us 97.306 minutes. So so we have here the departure 97.306 meters. Now take note that the direction of our line is from north to east. So therefore our departure, since it is going to east, this will be positive. If it is west, then that is a negative departure. So we have here positive 97.306 meters. Next is we have the line BC. So BC departure is equal to the distance, so we have 645.38 meters times the sine of the bearing angle, which is 85 degrees 46 minutes, and this will give us 643.619 meters. And since the direction of our line is going east, so this will be positive. So we have here 643.619 meters. For our line CD, we have departure is equal to the distance, which is 467.86 meters times the sine of the bearing angle, which is 18 degrees 13 minutes, and this will give us negative 148.454 meters. So it is negative since the direction of line CD is going to west, so this will be negative 148.454 meters. Next, we have line DA. So departure of line DA is equal to the distance, which is 593 times the sine of the bearing angle, which is 77 degrees 35 minutes, and this will give us negative 579.13 meters. So it is negative since the direction of our line DA is going west, so this will be negative 79 0.13 meters.